do that. We review full screen. Oh. All right. So now we're going to practice. Coefficient of friction, mu, is parallel over perpendicular. Sliding force, so force to overcome friction is the force that we use to slide it, over normal force, which is typically the weight. All right, so using that ratio, and we'll use 10 meters per second squared for gravity. I want you to find mu if, there's our block with the tread on it. I have a 2 kilogram mass being pushed with a 6 Newton force. I want you to tell me what mu is. I usually draw it like this because, remember, it's the nature of the two surfaces that dictates what mu will be. So try it right now. You don't even need a calculator. If you want to use a calculator, if that makes you happier, go ahead. When you think you've figured out what mu is, share with your shoulder partner. Who agreed with their shoulder partner? Jacob, what'd you guys get? 0.3 is correct. So mu will equal parallel, which is that 6 Newton force, over perpendicular, which is 2 times 10. We're using 10 for gravity, so over 20. Units? None. Very good. No units. Okay, so mu is less than 1 in this particular case. All right, now I'm going to take the same idea, but remember we added a sandbag. So now, if mu is 0.3, that's the nature of the two surfaces. We didn't change it. But let's say we have a 4 kilogram mass. Now how hard will we have to pull or push to slide it? To overcome friction, how big is F? This time, when you get this, looks like you're still finishing, I want you to check with your face partner. Is that what they're called, the person sitting across from you? That's what is that what, like, other people call it? Yeah. Call it your mirror partner. Okay, if we do mu equals parallel over perpendicular, we're trying to find the parallel force, the force to overcome friction, divided by the perpendicular, which would be 4 times 10, or 40 newtons. And I heard lots of you say 12 is the right answer. That is correct. All right, now let's make it just a touch harder. Now, at the same picture, and, we'll leave it as 4 kilograms. But this time, we're going to pull on an angle, just like I demonstrated. And you will need your calculator this time. And we'll still have mu be the same. So mu is 0.3. And my question is, let's see, if up here, if we look, I needed 12 newtons pushing parallel. What if I use 12 newtons? So it's not going to quite be parallel, but remember, when we pulled at an angle, it made it a little easier, right? Because we were lifting it up. So I want you to tell me, will it slide? And you have to have some math to justify that. So I'm thinking, based on the demonstration, it should slide, right? I don't even know because I haven't done the math yet. But will it slide under these conditions? See if you can figure that out. And I will do it myself. Yeah, we'll still use 10 for gravity. Good question. And I apologize for being a little short on time, but we only have a couple of minutes, so. Oh, so close. Just worked out that way. Because of time, guys, I'm going to solve this. I apologize. Hopefully you got some of this. I'm hoping that you're getting really good at finding these two components. Jimmy, what's this component right here? Yeah, which trig function do you, what? Yes, that is correct. And soup beer, what would this component be? That's all right. Because this is the hypotenuse. 12 is the hypotenuse. Because I just said it. Like, remember when I did the demonstration? So now I'm saying, remember we said up here, 12 made it slide, right? But now what if I do 12 but on an angle? And the question is, will it slide? Is that no? This is less than 12, right? But we're also going to make it lighter because of this component. Johnny? Yeah, that is correct. 12 sine 25 is the vertical. So the normal force now is going to be reduced. The downward is 40 newtons, right? Because we're going to use 10 for gravity, 4 times 10. So the whole perpendicular force will be, the normal force will be 40 minus 12 times the sine of 25 degrees. If you do that, you get about 35 newtons, okay? And 12 cosine 25 is less than 12 is 10.9. Now the question is, since I've reduced the weight to 35, is 10.9 enough to slide it? Does that make sense? That's really what's happening here, is we've reduced the normal force, and so how would you be able to tell? What can you do to test that mathematically We did it in the real world. Now, how do we make the math world prove this out? Compare the ratios. That is good. So mu is parallel over perpendicular. The parallel force, 10.9. The perpendicular force, 35, right? Remember, we took off some of the vertical. And when I divide that, I get 10.9 over, what do we get? 0.31. That's why I said, oh, so close. So now, will it slide? It'll slide when mu is 0.31. That's what this means. So what if mu is a little bit less than that? Will it slide? Answer starts with a J, ends with a U. Just barely, yeah. Very good. Well done. Yeah. Language girl over here, the rest of you are going, just the math kids, just Does that make sense? In other words, it's really close. I just randomly picked 25 degrees, and it was very close. All right. You do have homework tonight, and it's to do 3 problems just like this. I will put it on the corner of my desk up here, so grab it on your way out. And for Amos, I will make sure it's available online. So take one of those. There's a front and a back. You just need to do 1, 2, and 3 tonight, okay?